All right, so this is the last notes from Unit 2, and this you should be starting this homework on Monday the 14th, which I'm not going to be here in the afternoon because I have a doctor's appointment. But anyway, we are going to be doing the rest of the trig functions. You already had these first two. The derivative of sine with respect to x is cosine x. Derivative of cosine of x with respect to x is negative sine x. And then we have derivative of tangent is secant squared. Derivative of secant is secant tangent. And the derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. Something you should make a note of is anytime you do the derivative, and it's a derivative of a trig function that starts with a c, they are all negatives. So make sure you make a note of that. So we're supposed to prove that the derivative of the tangent of x equals secant x. So we're going to use some old stuff that we did this with. So that we're going to change the tangent to sine over cosine x with respect to dx, which this is going to be a quotient rule. So we do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So when we simplify that top part, we get cosine squared x plus sine squared x all over the cosine squared x. And then I hope we remember that top part is a Pythagorean identity, which is 1 over cosine squared x, which when you do the reciprocal equals secant squared x. So that's the proof of it. Not a big deal that you know that, but that's how you prove the derivative of tangent is secant squared. Now we're going to find the derivative of each of these. So this one is going to be some of the stuff we did before. So when I do the derivative of y, the derivative of x is 1 times 1, which is 1. Subtract 1 from the power, so the x is gone. And then it's minus the derivative of tangent is secant squared x. Now, you might leave this like that, but we're supposed to know that tangent squared x plus 1 equals secant squared x from old identities. So what that means is we can simplify this whole thing, and we can take in where the secant squared is and put minus, and then we can plug in this tangent squared x plus 1, and then you distribute the negative sign, and that negative 1 and that 1 cancel out. So we could simplify this thing just to negative tangent squared x. Any one of these would be fine. Now this is a product one right here. So we do the product. We're supposed to do the derivative of y with respect to x. And remember, I'm writing both these ways so you can see they mean the same thing. And we're going to do product rule. So it's the first term, which stays x, and then we want to do the derivative of secant x, which is secant x tangent x. And then it's plus when you're doing product rule, and the second term is secant x, and then the derivative of x is 1. Now you don't have to put the 1 there because 1 times anything is the same thing. And then we could write this some different ways. This is fine, but we could also factor out a secant x here. And that would leave x tangent x plus 1. And we could leave it like that, or we could do some more stuff. We could make this 1 over cosine, and that's sine over cosine, and try to simplify stuff there. But it's really kind of a big deal that we just make sure we know our trig identities that I put on the back of that sheet I gave you quite a while ago that had all of those old terms in it. Okay, then this next page is kind of a reminder of some identities. So one of the identities I just gave you, or that we talked about, was sine squared x plus cosine squared x equals 1. And from this one, you should also know that sine squared x can equal 1 minus cosine squared x. And if you take and subtract the sine squared x over there, you should also know that cosine squared x also equals 1 minus sine squared x. And another one I just told you a minute ago was that 1 plus tangent squared x equals secant squared x. Okay, and then from the same rules, if I subtract tangent squared x from both sides, You hopefully remember that one. And then also you can subtract 1 over there and get that tangent squared x will equal secant squared x minus 1. And then there's a third identity for Pythagorean identities. And that's the one that, and by the way, I probably should have told you this. To get this one, if you divide everything over here by cosine squared, sine squared over cosine squared is tangent squared, cosine over cosine is that 1, and 1 over cosine squared is secant squared. The other thing we could do to this thing is divide everything by sine squared. So if we do sine squared, we get sine squared over sine squared is 1 plus cosine squared over sine squared is cotangent squared x. And then 1 over sine squared equals cosecant squared x. So this is another Pythagorean identity. And I'm going to subtract 1 from both sides. And I'm going to get that cotangent squared x can be secant squared x minus 1. And then you could also subtract cotangent. And you would get this. So those are all the trig identities from pre-cal. Now down here, you're supposed to take this side. You're supposed to work with a partner, but since we're not partnering because of COVID, you can do it with a partner or check with a partner, but you're supposed to take both these sides here, and you're supposed to do the derivative of this left side using quotient rule, and the derivative of this right side using the old things, and show that you can get them equal on each side. So if you want to get a partner, have one of you do the left side, have one of you do the right side and show they're equal. If not, you can do both sides and show they're equal. I will see you guys on Tuesday. Have a great day, and I will talk to you later.